Hello everyone, welcome back to my channel. So till now we have discovered constructors and we also learned about constructor overloading and also this keyword. We know why to use this all stuff, correct? Yes. So now today, as we have discussed, that we are going to learn about operators and how many kind of operators do we have. So let's get started, but before that I need to distinguish between operator and operands. So operators are the operators that we use like plus, minus, multiplication, division, modulus, correct? Yes. So these are the operators that we can use. So these are the example of operators and there are lot more. Now operands. Operands are something on which we perform some operation using operators. So let's say I am saying a plus b. So this is the operator. And this a and b are nothing but our operands. So I hope it is clear to you all. So now first I'll tell you there are different kinds of operations. Okay, but before that I'll just tell you that what kind of operators that we are going to learn. So we are all together going to learn 7 kinds of operators in Java. Okay, so first one we have already saw, assignment operator. So let me give it a quick recap of it. So you say assignment. What do you mean by assignment? Means assigning some values, correct? Okay, so have you assigned any values to someone? You have, correct? You have assigned 10 to a, am I right? You have assigned some value to a. So this equal to is nothing but your assignment operator. All right, so we usually write syntax like int a is equals to the string a is equals to string name is equals to some value. So this equals to is nothing but it is doing some operation, that is it is assigning this value to our variable, correct? So this is a kind of operator and the type of operator it is a assignment operator, correct? So now other operators we have arithmetic operators. We'll learn arithmetic operators. Okay, so but before that I'll just explain you 3 kind of operations: unary, binary and ternary. Okay, so unary performs on 1 operands. Okay, so unary operation works on 1 operand, binary on 2 operands and ternary on 3 operands, correct? Yes. So this is something that we can guess. We'll see example of each one of them, but you know what are operands? Like for example a plus b, over here how many operands do we have? 2 operands. So this is a kind of binary operation. If I say a plus plus, how many operation, or sorry, how many operands? 1, a single operand, which means it's a unary operation, correct? Now ternary is a kind of like it have a different syntax, but we'll discuss this syntax as well. Okay, don't worry about this. Okay, so don't worry about this ternary operation, but now we are going to deeper into this topic. Okay, so yes, so in arithmetic operators we all know yes, so arithmetic operators we have plus, minus, for multiplication we used asterisk, for division we use forward slash, and for modulus we use percentage symbol. We'll see how we can use each one of them. So the first one is very obvious. If I do a plus b, or I can say 10 plus 5, so we'll get the resultant as 15, am I right? If I do 10 minus 5, we'll get 5. If I do 10 multiplication 5, what output will get? We'll get 50. If I get 10 divide by 5, so what output will get? We'll get 2. But now this thing you might be knowing this, but then too it's my job to explain you this. So this modulus is nothing but if you do 10 modulus 5, okay, so the modulus returns the remainder. Okay, so what is the remainder if I divide 10 by 5? See, the remainder is 0, correct? If I divide 10 by 6, what will be the remainder? The remainder will be 4. Am I right? If I divide 5 by 2, what will be the remainder? 1. So if I do 5 by 2, or I can say 5 mod 2, sorry, yes, if I say 5 mod 2, what output will get? Will get the remainder as 1. If I say 10 mod 5, what remainder will get? 0. 10 mod 6, what remainder will get? Will get 4 as the remainder. So let's try this all out and then we'll proceed. I know it's kind of basic stuff, but then too we need to learn this as well. So if I say system.out.println 8 plus 7, what output will get? Will get output as 15. Instead of this, if I say 8 minus 7, what output will get? Will get 1. If I say 8 asterisk 7, you would have already guessed the output will be 56. If I say 8 divided by 7, now one thing we'll see why we are getting 1, why not 1.1 or some values like this. Okay, so don't worry about this because we need to learn about operand promotions. Okay, so if I do 8 mod 7, so what output will get? See, 8 divided by 7 will get 1 as the remainder. Am I right? Yes. If I do 8 divided by 5, what will be the remainder? The remainder will be 3. Okay, so I hope it's getting clear to all of you the use of arithmetic operations, and we'll see some examples of this. So for example, if I want to check, see, you already know the use of plus, minus, division and multiplication. Now one thing that I will help you to understand is you can use modulus operator. Let me take an example of you want to find out whether a number is even or odd. So you will check some condition. If the number, let's say the number is n, modulus of 2. So if anything divides by 2, which means it's a even number, correct? Which means if 10 divides by 2, what will be the remainder? The remainder will be 0. So if remainder is not 0 or is equals to 1, correct? If 11 is divided by 2, the remainder will be 1, which means 11 is a odd number, correct? So if I say if n modulus 2 equals to 0, don't worry about this one as well, we'll see logical operations as well. Okay, so which means we can distinguish between the even and odd. Okay, and we'll try this example when we move to conditional statement as well. All right, so now yes, so we can also perform some operations. Okay, so let's take the example of unary operation. We know binary operations, correct? A plus b. Am I right? Yes. If we have done that as well, 10 plus 5, or over here we did 8 plus 7, so we get the output as 15. So we have done with binary operation. All this operation that we did over here were binary because I was performing operation on 2 operands. But now let's say unary operations. Okay, so let me define a variable. Let me give the variable name as a, and let me give it a value as 7. Okay, now what I'll do, I'll say a plus plus, which means I have to increment the value of a, correct? So if I try to invoke this over here, what output will get? Will get 8. Am I right? Yes, correct. So if I do it again, a plus plus, what output will get? Will get 9. Great. Now, all right, so now one thing that we have to understand, there are two kinds of unary operations. So over here we were doing increments, correct? So I was incrementing a by 1, correct? But now there are two ways of incrementing a. The first is post increment and the second is pre increment. So the difference between them, you might have already seen the syntax like this. Now the question is that what is the difference between them? Sorry, yes. So now what is the difference between them? Both of them are incrementing a, am I right? Yes. So now we need to understand that how this thing happens, post increment and pre increment. So this thing says that you have to first increment the a, then you have to perform some task. Okay, so let's say the value of a is 6 and 6 over here before the operation. Okay, now as soon as I perform this operation, it will say before doing anything you have to first initialize 8 to 7 and then it will perform some other task. And this will do what? This will do, you do first, like you have to perform the task first and then you execute this. Okay, I know it won't be clear for now. So let us test whether both of them work same or not. So if I do this, yes, we get the output as 8. If I do this, can you see the output? The output seems to be different. We get the output as 7. So the reason for this, okay, so I'll explain you the reason. So for example, if I say system.out.println plus a, and the difference between system.out.println a plus plus. So now the difference between them, this says that you, before doing anything, what is anything over here? I have to print the value of a. This is our anything, correct? So before doing anything you have to increment the value of a. What is the value of a? 7. So I will increment it to 7, oh sorry, to 8. So it gets incremented to 8 and now it is going to print it. But now what it says? It says you do the task first. Okay, I am not in a hurry. You print 7 and then you increment the value of a. Okay, so after this operation, if I try to print the value of a, it will be 8 only. But this happens after performing this operation. Okay, so let us give it a try. System.out.println. I'm just printing a. See, can you see the output? Yes. So this is the difference between pre-increment and post-increment. Okay. So now, and even the name suggests pre and post. Post means you have to do something afterward and pre means you have to do something before or prior to some task. Correct. So this is how the increment works. So let me give you some examples as well. So yes, let us take an example. Int a, the same example. Okay, b is equals to a plus plus, and I am having int b is equals to plus plus a. If I try to print system.out.println b, and even I do system.out.println a, and over here system.out.println a, system.out.println b, correct? What will be the output? You have to guess this. Okay, so this is clear, a is 7. Okay, you have to post increment it, which means you have to first assign value of a to b and then increment a. So what will be the value of b? Value of b will be 7, and what will be the value of a after this statement? It will be 8. Okay, so this is the output that we are going to get, and over here it will say you have to first increment the value of a. Okay, so first you have to increment the value of a and then you have to initialize it to b. So over here we'll get output as both 8. So let us try this out as well. All right, so let me have, yes, a plus plus. Okay, I am trying to print a and b. Yes, so can you see the output? It is 8 and 7, and if I just change this operation, if I make it as pre-increment, the output is 8 and 8. So I hope it is clear. Yes, so this is again, like, you might get some MCQs based on this, so I hope now you won't be making it wrong. All right, so now let's learn about ternary operations. So ternary operations, we can say that it is a shorthand for if else. Don't worry about that. Again, what are if else, we'll learn that. So ternary operations. So if I say 10 greater than 7, okay, over here if I say 10 greater than 7, I use a question mark and a colon after this and I give some value. So over here I'll say true and then I'll say false. You can give any value over here, okay, it's up to you. You can give 0, 1 or 10, 20, it's up to you. Okay, so I have given these values like this. All right, so now how this works, it checks this condition first, and if this condition is true, it will perform this task, otherwise it will perform this task. Or I can say that it will return true if the condition is true and it will return false if the condition is false. Am I right? So yes, so now let me take an example. All right, this is false. Yes, so now see what will be the output for this. It will first check this condition. Is it true? No, it is false. Then it will print 11 or it will return 11. Okay, and if the condition is like this, so the condition is true, which means it will return 10. So let us try this one as well. So can I do it in system.out.println? Let's try this. So let me wrap the condition inside this, 10 greater than 5. I'll use question mark. I'll say 10, otherwise 5. Okay, so now let me print this and we get the output as 10 because the condition is getting true. Now the condition is getting evaluated as false. That's the reason why we are getting the right part. So if the condition is false, we get the right hand side of the colon as a output, and if the condition is true, we get the left hand side of the colon as the output. Yes, so I hope it's clear to everyone. So now we have covered operations like unary operations, binary operations and ternary operations as well. We have discussed about arithmetic operators. Yes, so I hope till now it's clear to. Is true always in the first position? No, as I said, you can give any value. You can give false as well over here. This is the output that you want, but based on the condition it will give. If the condition is true, then it will give this output, and if the condition is false, it will give this output. So it's up to you which you choose. All right, yes, so now we are going to learn about comparison operators. See, all these operators are going to have a great impact when we learn about loops and all. Okay, so it will be of great help. So we have to understand them thoroughly. All right, so now we are going to learn what are comparison operators, but before moving to that, we will learn some shorthands. All right, so we have discussed arithmetic operators, correct? In this I said that, all right, so if I say int a is equals to 10, this is assignment operator. If I say a plus 5, this is a kind of binary operations, correct? First operand, second operand and the operator. Am I right? Yes. So you will declare it as, so if you want to add 5 to it, how you will do? You will do a is equals to a plus 5. Am I right? Which behind the scene will be evaluated as 10 plus 5, correct? So the another shorthand for this is, you can say a is equals to 5. Okay, so this and this, both of them are similar. Okay, so if you want to do a minus 5, you can also say a minus equals to 5. Both of them are again same. A multiplication equals to 5, a modulus equals to 5, a division equals to 5. All this arithmetic we get, means with all this arithmetic we get some shorthands. So let's try this one as well. So let me declare a variable int z is equals to 6. Now if I say z plus is equals to 5. Now if I do system.out.println, and if I say this and let me print this, we get the output as 11. So now what happens over here, you all know that okay, it is 6. Now what I am trying to do is I am trying to initialize z with z plus 5, correct? So 6 plus 5 is equals to 11, and this is what we are getting over here. Yes, so I hope these shorthand operations are also clear to each one of you. Okay, and they are also called as compound operations or compound arithmetic assignment operations. All right, yes. So now we have completed the arithmetic session, the arithmetic segment, but one thing that we have still left is, what if I have multiple operations like this, correct? So see, you know the BODMAS rule that we have learned in school, correct? So you know that the division is always going to get the first preference, then the multiplication, and then the other operators, correct? So you know all this stuff. So let us try this one as well, and then you can refer your normal BODMAS rule. Yes, so if I say 10 plus 15 divided by 3, all right, so what will be the output? Will it be 10 plus 15, that is 25 divided by 3, that is 6, or will it be 10 plus 15 divided by 3, that is going to be 5? Will it be 15 or 6? Let's see this. According to our BODMAS, we guess it will be 50, because as I said, the division will get the first preference, so it will divide it first, and then 10 plus 5 is equals to 15. So we can just relate it with our normal BODMAS rule. Yes, so the 15 is the output for this, correct? All right, so if I have multiplication after this, okay, so if I multiplication after this, let's see what the output do we get. We get the output as 20. So let's check, is it like this? Okay, first division is going to take place 5, then the multiplication, that is going to be evaluated as 10, and 10 plus 10, that is equals to 20, correct? So now yes, correct. So I hope it is clear to each one of you. Okay, yes, and now you all know, even in the school mathematics, when we want to perform this task first, we can give them inside the brackets. So now what will be the output? Let's see this, it is 12. So first this thing going to get evaluated, then it will divide 15. So what is the output for this? 2, and 10 plus 2 is 12 again. It is not giving the value in int, and we'll discuss this. Okay, so now let's first discuss this thing, and then we'll move down to the comparison operators. Okay, so now you have to note some points. Okay, so yes, note some points, that operands, now you know what are operands. The a plus b, in a plus b we have the operands as a and b, correct? So operands that are smaller than int. Okay, operands that are smaller than int. Who are the operands? Means, so what are the types that are smaller than int? Byte, dot, and char as well, correct? Yes, so if I am having any operands like this, okay, then it will be promoted to int. Okay, it will be promoted to int. So what do I mean by this? So let's say if I am having a variable, two variables, okay, byte a and byte b, okay, I can store this value. Now whenever I perform any operations, okay, over here I mean any operations. So if this is a kind of operation, because I am using a operator, so what happens before executing this task? Okay, before All right, let me just byte A, byte B, 1, 127. Yes, correct. So if I say A plus B, this is a kind of operation. We are doing the addition operation. So before performing the operation, before going directly to before directly giving the answer, what happens behind the scene, that we are going to learn. Okay, so what happens behind the scene is this A is of type byte. So let's say it is byte. I'm just giving this for your references. Okay, plus I am adding a byte kind, and then I want the result, correct? So I am having this operation. So as I said, if any operand is smaller than int, then what will happen? The operands will be first promoted to the int type, correct? So now let me tell you what happens behind the scene. This first gets promoted to int, okay, and then this gets promoted to int. This is the behind the scenes stuff, okay, and now we get the resultant in the form of int only, not in the form of byte. Okay, so just make sure. Okay, so that's the reason why when I was typecasting some values previously, correct, we were always getting the output as we cannot typecast from int or some values like this, correct? Yes, so this is the main reason, because if any data type is smaller than int and I am performing any operations to it, it first gets converted to this int type. Okay, so now let us practice this. Byte A, all right, A will be there. Let me give I 8. Byte J is equals to 9, and byte K is equals to I plus J. Can you see we are getting a error? Am I right? The error says that type mismatch, cannot convert from int to byte. Now your question will be, where is int? I am not having int at all over here. First is of type byte and the second is also of type byte. If I am doing byte plus byte, 8 plus 9 and 17 can get accumulated inside K, because byte range is the up to 127, but then too we are getting an error that cannot convert from int to byte, because for performing this we need some explicit typecasting and we have done that. But now the question is, why do we get these errors? Am I right? See, we get an error. Let me again show you. Type mismatch, cannot convert from int to byte. So this is the reason why what happens behind the scene is, at this time, okay, I plus J, I is of type byte and this is of type byte, but though I am doing over here, since I am doing a operation, it first gets converted to int and then int. Am I right? So the resultant will be definitely in the form of int, and int is of 4 bytes, byte is of 1 byte. So that's the reason why we get an error that cannot cast from int to byte. So I hope it is clear to each one of you till now. This is something called as operand promotion. So you must be aware that why we are not getting any other, or why do we get such kind of errors, because if we are using any small values, so that's the reason why in our data type session I have told you that you should stick with int, because anything that is smaller than int, as soon as you perform any operation, it is going to get converted into int only. So that's the reason why it is again a best practice to stick with int, and if the number range is really big and a fixed number, then you use long. Am I right? Yes. All right. So now one thing. Okay, so I hope till now it is clear to all of you that why do we get this error. So let me just comment this stuff out. Yes, now another topic. Okay, another thing that we are going to learn, if two operators, see now you know the operands smaller than int, but now operands greater than or equals to int, correct? Now the rules for this, you know the rules for this. Now the rules for this, so if the operands are of same type, okay, let's say int and int, okay, if I'm doing int plus int, we'll get the resultant in the same type. Okay, so the resultant will be of the same type. If I am having long plus long, the resultant will be of the same type, that is long. And one thing, if we have different types, I know this question might get arised, correct? So int plus long, so the resultant will always be the bigger one, because what happens at this moment of time, this int first gets converted to long. Okay, so now it happens to be long plus long and we get the resultant as long. All right, so now if I am having float plus double, what will happen? The float will first get converted to double behind the scenes, we are not doing it explicitly, and double plus double will give us the result as double. Am I right? All right. Yes, we can resolve that error by changing the type of k to int. So let me do that one as well and let me show that it works. Yes, because you definitely know that if it is returning int, then I can store it in int. See, the error is gone. All right, so it's up to us, but yes, it was just for learning that concept. Yes, so now over here what we are doing is we have completed with the first stuff. Now the second stuff for the operand promotion is this: if both of are the same type, then no issue, we'll get the resultant at the same. But if they are of different type, then the smaller type will be converted to the bigger one and then we'll get the resultant output. So now let me tell you, okay, yes, all right. So now you knew that when I did 8 divided by 7, I get the output as 1, and I said that no worries, we didn't get output in points. Am I right? Means we didn't get output as 1.17 or some 1/4 values like this, correct? We didn't get values like this. So the reason for this, I did 8 divided by 7. Now if I say any number, if I write any number, let's say 100, 9, 10, which it will assume that which kind of data type it is having, it will always assume that it is int. Am I right? So that this we have already discussed. Whenever you are writing a number, a fixed number without decimal, it will be considered as a int, and if you write any number as decimal, then it will be considered as double. Am I right? Yes. So now what is the type of this? This is a type of int. Int divided by int, the resultant will be in the form of definitely int. Okay, int cannot hold any decimal, so it will always get truncated, and we have already discussed this, correct? So that's the reason why if the resultant or if the operands are of same type, we get the resultant of the same type. So I hope it is clear to all till now. Okay, yes. So now let us try this one as well. Yeah, so if I say system dot out dot println 8 divided by 7, we get the output as 1, 7.0. See, as soon as I make it as 7.0, can you see the output, the change in the output? What happens? 8 divided by 7.0, first is of type int, second is of type double. Okay, which one of them is bigger as per the data type? Okay, not the value, this is the bigger data type. So now this will first get converted to double. So what will be the value for this is 8.0. 0, and 8.0 divided by 7.0, the output will be always in the double, and double can store the decimals. So that's the reason why we are getting a output as this. I hope it is clear to all of you. So these rules, yes. So we have discussed the mixed type as well. See, we have discussed the same type, the smaller than int type, greater than int type, and this was the mixed type, correct? Yes. All right. Okay. So now, yes. Now let me tell you, if I do this way, you know this syntax, correct? Double, what output do we get? We get the same output. Can you guess this? So this is the reason why, this is what explicit typecasting. And now can you see the use of explicit typecasting? If we want, like, you know that the value a and b will always be of int type, but you want the resultant in the double type, then you do what? You use explicit typecasting. You are not going to change the type of this, you are just changing the operations on them. So this will get the resultant in the double form. So this is the use of explicit typecasting, correct? All right, so you are asking that can I repeat byte plus byte? All right, I'll repeat that. Byte a is equals to 7, byte b is equals to 2. All right, you know the range for byte is minus 128 to positive 127, correct? So 7 plus 2, that is 9, can easily get stored inside this. So you will think, yeah, I can store 9, so I will do byte c is equals to a plus b, and now you will be expecting that, all right, we won't get any error and c will give us the output, or 9 will be stored inside c, but we'll get an error, and the error will say that we have a type mismatch, I cannot convert from int to byte, which means the compiler says that this is a kind of int and this is a kind of byte. I cannot store the bigger data type inside the smaller if you are not doing it typecast. All right, so now we have seen the reason that if the operand is smaller than int type, there is a promotion of the operand to int. Okay, so the first operand is a is of type byte, correct? We are operating on with b, it is also of type byte. So what happens? It gets promoted to int. Okay, and then the operation get performed. So both of them are of type int. What will be the resultant type? It will definitely be int. So can I store int inside it? No. So that's the reason why we get an error that I cannot convert from int to byte. So I hope it's clear now. Yes. Okay, so we have discussed this. So if I am having values like 1 divided by 2, what will be the output? 0. If I do 1 divided by 2.0, what will be the output? 0.5. If I have 1.0 divided by 2, again 0.5, because double plus int will get promoted to double. Am I right? Yes. If I have character plus float, what will be the output? Float is the bigger one, will get the resultant as a float, correct? Float plus float will give us output in float. Double plus double, double. Float plus double will get the resultant as double. So I hope till now it is clear to all of you. Now let me share you one interesting example, not that much interesting, but then too we can go through it. All right, if I say 20, yes, now can you see the output? What is the output? We are getting 20.1. Now at this moment of time you might think like we would have got some different values. What happens over here? This 9 divided by 5 into 20.5. As I said, the promotions or this rule are applicable when we perform some operations to it. So the first operation, is it like this way that the whole operation is going to performed at once? No, the first operation is 9 by 5. Am I right? So what is the type of 9? Int. What is the type of 5? It is again int. So what will be the resultant? It will be of type int. So which is the closest or the floor value of the int if I divide by 5? So 5 ones are 5. So we'll get the output as 1.8, I guess. But since the resultant is of type int, I cannot store a 0.8. It will always truncate. So we'll get 1 over here. And then the next operation says that it is 20 plus 1. So what happens over here? This is of type int and this is of type double. So now this gets promoted to double. So this will get promoted to 1.0, that is of type double, and then it will be multiplied by 20.1 because it is also of type double. What will be the resultant? If multiplying this, will get the resultant in the form of double, that is 20.1. So don't get confused with these scenarios as well. Yes, all right. So do you have any doubts till now? Yes, definitely we'll get the output as 20 plus 1. Right. Yes, so you are asking that if the operands, okay, so you are asking that if the operands are of type int and float, what will be the resultant? Now you tell me which of them are bigger. The float is the bigger than int, correct? So we'll get the resultant in the float only, because what happens behind this int is going to get converted to float. So float plus float will definitely give the output as float. Okay. Yes, float plus int will always be giving us the output as float only. Float plus int, yes. So if it is, again you are asking again that float plus int, see, you are human, so you can see this, but compiler don't have eyes. This thing and this thing is again the same. Okay, this is float, I'll keep it for now. This is int. Which one of them smaller? Okay, this is smaller, correct? So I have to translate it or convert it to float first, and then I need to perform the operation. So float plus float, and the resultant will be float. Great. So now let's move ahead. I hope we have completed a lot in this arithmetic operations. Okay, so now what we can do is, see, what we have done till now is yes. So now what we'll do is we'll do some comparison operators. Okay, so what are comparison operators? You all know we need to compare some values. Okay, so if I say a greater than b, a smaller than b, okay, so these are nothing but we are comparing it. Am I right? Yes, so these are nothing but the comparison operators, and we'll see that thing as well. And now we'll have some demonstration of this thing as well, like how we can use the comparison operators. All right, so don't worry about this. Okay, so yes, so if I say 10 greater than 11, what will be the output? We'll get the output as false because it is false. If I say 10 smaller than 11, we'll get the output as true, correct? So right, let me perform system.out.println 10 greater than 11. We don't need to define any variables for now because we are just learning the operators. We get the output as false if I give it in a reverse way. Okay, Now we get the output as true. Now one thing, yes, so now one thing that we have to learn, okay, there are equal to operators as well, okay, equal to operators. So this equal to operators checks whether the value is equal to this value or not. So if I say a equals to b, so now the question is, why not a equals to b? Why do we need 2 equals to sign? Correct. So I'll just tell you to recall, why do you use equal to sign? You use equal to sign to initialize a variable, and if you do it like this way, then it is not going to compare it, it is going to assign the value of b to a. So that is the reason why we have to make something unique. So that's the reason why they have made it as like a equals to b. So I hope it is clear. So if I say 10 equals to 10, what will be the output? The output will be true. If I say 10 equals to 11, the output will be false, and this is so obvious, correct? So let me say 10 equal to 11, will get the output as false. And if I say 10 equal to 10, what will be the output? Will get the output as 10, correct, because 10 is equals to 10. Okay, now one thing other is we have not equals to. Okay, we might get some scenarios where we want to check if it is not equal to this value. So if a not equals to b, then what will be the output, correct? So if I say a not equals to 10, is it true? Yes, it is true. So we'll get the output as true. Yes. And if I say a not equals to 10, is it true? No, it is not true. So we'll get the output as false. So you are saying that yes, equal to is comparison and equal to is assignment, correct? So that's the reason why we use equal to. So now I am using not equal to. So now let me, if I give not equal to 10 over here, so what will be the output? Will get false. If I say 10 not equals to 11 or 10 not equals to 110, then we'll get the output as true, correct? So let us try this one as well. So for saying not, we can use the exclamation mark. Yes, we get the output as false. If I say not equals to 170, we'll get the output as true, because it is not equal to 170. 10 is not equal to 170, correct? Yes. So I hope you are getting a better understanding of operators for now. What you are asking, true in binary numbers, zeros and 1. See, zeros and 1 are just a simple int variable for Java, correct? And for booleans we have true and false, correct? Yes. So now, yes, so now I hope it is clear to all of you that what are comparison operators. We have discovered the comparison operators and it was quite easy task, correct? Now one thing that we need to learn is greater than or equals to and less than or equals to. So what do I mean by this? Okay, so if I say 9 greater than 9, is it true? No. But if I use equals to sign, so it will check whether it is greater. Okay, if it is not greater, is it equal to this? Then it will return true. So over here we can check two conditions, if it is greater or equals to. So if I say 9 is less than or equals to 9, then too it will give the output as true, because okay, it is not less than but it is equals to, correct? So if I say 9 less than or equals to 90, again true, because 9 is less than. If I say 90 greater than 9, again true, because it is greater. Okay, so this is how we can use these operations, and let us try this one as well. So let me say system.out.println 9 greater than or equals to 9. Is it true? Yes, definitely. And if I say only greater than over here, what will happen? We'll get false, because 9 is not greater than 9, it is equals to 9, correct? Yes. So now if I say less than or equals to, again we'll get the output as true, correct? So this is the reason why we can use this equal to sign so that we can evaluate whether it is smaller or equal, but like we have the upper bound, okay, over here. If it is less than, then okay, we'll get the true value as well, like it is, let's say 0 1 2 3 4 5 6 7 8, and I'm comparing it with 9. All these values I'm comparing one by one with 9 will get true, but as soon as I introduce 9 will get false. But if I want to include this 9 as well, I can use the equal to operator over here. Yes, definitely the comparison operators are of type booleans only, because we are getting the output as true and false, correct? So we always get the values from comparison. See, how do you compare someone? If I ask A is taller than B, you will say yes or no, correct? Yes. So this means we get a obvious answer. Am I right? True or false? If A is equals to B and I am asking that A is greater than B, which means like I am saying that if A is 10 and B is 10, and if I use this operation, then you will say false because they are equal. So it is giving us the obvious answers. Okay, so the answer can be only true or false. Okay, they don't like make round and round in giving the answers. It is just giving us the actual answer, the exact answers. Okay, so it is returning us the type boolean, the true or false, but either one of them. All right, so we have completed this thing till now. Now let us learn logical operators. What do we mean by logical operators? I hope it is clear to every one of you, and if you have any doubts you can ask me. So now what do we mean by logical operators? So some of you have learned logic gates as well. So if I say A equals to 0, B equals to 1, I need to check both the condition, and if both the condition are true, then only I need to give some value, or then only I need to print the true values, correct? If I check over here, let me define some variables. Int A is equals to 0, int B is equals to 1. Okay, it is not always needed to write codes over here. I am writing it over here as well, correct? So yes, if I say I want to check over here, I was giving value on two operators, correct? But now I want to check multiple conditions like this at one line. Okay, I want to check whether A is equals to 0. If I do this, what will be the output for this? True. If I check B is equals to 1, what will be the output for this? Is true. So I want true if both of them are true. Okay, if this is 10, then this will return false over here. Am I right? And if it returns false, I don't want the answer as true. Okay, so I introduce and. Okay, so now again your question will be why two ands? Let me declare the variables again. Yes, so your question will be why two ands? Again, we'll see why we have two ands, why not one. The significance of one and is different. We'll see that in our next session, don't worry. Okay, so I want to check multiple conditions and I want to return true if all the conditions are true. Okay, so I want to check A is equals to 0 and then B is equals to 1. So if both the condition returns true, then only I will return true. Okay, so if I write 10 over here, this will return false, and if one return false, one return true, we'll get the answer as false. Okay, and if both of them returns true, okay, if both of them returns true, then we'll get the answer as true. So only when both of them returns true, we'll get the output as true, otherwise we won't get the output as true. So the AND operator checks the left hand side, then checks the right hand side, and then decides which output that we have to give. So now let us try this one as well. So system.out.println. Okay, so if I say 0 equals to 0, what output I'll get? I'll get true at the end. Am I right? Yes. Now if I say system.out.println 1 equals to 1, what output will get? Will again get true. But now I want to check both the condition and respond with respect to them. Okay, so I will write it over here and I'll introduce and. So I will give the resultant true only if both the side gives me result as true. Alright, over here I am getting true from both the sides. If I make it as 10 over here, will I get true from both the side? No. From the left hand side I'll get true, but from the right hand side I'll get false. So it will give us the value as false. So I hope you have discovered or you have understand that why do we need the and operators. Okay, so we have discovered and, now we need to discover or. Okay, so for or, okay, now or means either one, means if one A or B, or I can say LHS or RHS. Or see, you can use a normal English language as well for understanding this concept. Or means any one of them. Okay, if I say you do this or this, correct, you do 1 or 2, but if I say you do 1 and 2, it is quite obvious that and means you have to do both and or means you have to do either one of them. Am I right? So you can use or operators. So how do you define or operators? By two pipes. Okay, so if I say A is equals to 0 or B is equals to 0 or 1, let me take 1. So our A is 0, B is 1 for now. Yes, so this returns true and this returns true. What will be the resultant? Definitely true. But if B is 10, this will return false. But as I said, this is a kind of or operators. Either one of them value matters. Okay, even like if A returns true, then great, I'll return true. If B returns true, then I'll return true. But it will return false only if both of them return false. If this is also 10, then this will return false. And if both of them return false, then it will return false. Okay, so if either one of them returns true, then we'll get the output as true. Okay, yes. So now one thing that we need to know is, okay, A is equals to 0, B is equals to 1. One thing that we need to know is there are smart compilers. Okay, so what do I mean by smart compilers? A is equals to 0 over here, or B is equals to 1 over here. So smart compilers means if I'm getting true over here, is there any need to traverse over here? I don't want its value, correct? Even if it returns false, I have to return true only because one of them is returning true. Okay, even if it returns true, then too my value won't change. Okay, so if it gets true in the LHS, in the left side only, it won't traverse to the right side. So it will just keep this part. So this is how it increases its efficiency and reduces the time complexity for this program. Okay, so I hope till now it is clear to every one of you. And do you have any doubts? You can ask me now. Yes, so I know, like, I guess it is too much of stuff for now. We have discussed arithmetic operators, comparison operators, logical operators, and assignment. That was quite very easy, correct? We have seen unary operations, binary operations, ternary operations, and we have seen operand promotion. We have seen all the rules of them. Why do we need them? Means how that happens and how we can get the errors and how we can resolve the errors and why do we get such kind of errors. Okay, we have discussed, like, we have seen each and every syntax till now. Yes, now when practicing you might get some different errors or some weird values, but now I believe that you will be definitely guessing the output, like why it is coming out to be false or why you are encountering this error, because we have discussed, I guess, each and every aspect for this concept till now. And if you have any doubts, I'm there to help you always. All right, so I'll stop streaming for today, and tomorrow what we are going to learn is we are going to tomorrow discover some new operations, the bitwise operations, the bit shifts, okay, and we'll also see instance of operation. Okay, so these are the kind of operations that we are going to discuss in our tomorrow's session. So yes, again, these two are not that useful, or means they are not much used in the directly in the development or in the testing field, but then too we are going to get a understanding that how they work. But when you are doing competitive programming, these things you can count on this, because this helps a lot sometimes. Like there are questions based on this concept, but yes, when you are doing development or testing, it is not much used. But then too we need to get aware about this stuff, that how bitwise operators and bit shift operators works, and instance of, we'll see how this works. So in our tomorrow's session, we'll see how we can use these operators and what are the concept related to them. Yes, sorry, we'll have our next session on Monday because tomorrow is Saturday. Yes. All right, so I'm seeing the chat that someone is saying that they are going to start vlogs, include me as well. Yeah, so see you all on Monday. Thank you so much for joining, and if you have any doubts, you can just ask me in the comment section.